Hello, youngsters. It's math time. So we're looking at 5.3 coterminal angles. Let's get it going. So the idea here is basically we have this word called coterminal angles. Co means to share, so they're angles that share the same terminal arm. In this little picture here, we can see that 0 is the sort of standard over here in the x-axis. That's also 360. Hey, it could be 720, it could be 1080, it could be any multiple of 360 actually. And that sort of idea carries on for any of these angles. So this angle over here, which is in the second quadrant, if you go in the positive direction, you find that that would require a 165-degree rotation. But the idea with a coterminal angle is you could have another angle where you don't just rotate once, you rotate there, and then you do a full 360 on top of that to get 525. Or you could have went in the negative direction to get over there, which is negative 195. You can see that there's actually an infinite number of coterminal angles for any angle out there. Sometimes we'll put restrictions on so we don't have too many of them, but basically that's the idea. So the example, of course, is those are all coterminal. The principal angle, just like the principal of a school, is the least positive angle between 0 and 360 degrees. So for the most part, that's what we've been talking about. When we're doing solutions, we've been focusing on the angle between 0 and 360. So in the case of this, where we've got 3 coterminal angles, pop quiz, which one is the principal angle? And it turns out it's this guy right here, 165. Okay, so it's the least positive angle. You can't have negative principal angles, and it's always less than 360 degrees. So we have a notation that we use. All the coterminal angles, theta c, can be calculated by adding multiples of 360 degrees to the principal angle. That c is actually a typo. That should not be there. So the principal angle is theta, and then coterminal angles will be theta c. So what we can say here, I think that was supposed to be a p up there, so actually let me just go change that. So p is for principal, and I'll just have to fix that. There we go. Okay. Anyway, so the coterminal angles can be calculated by taking the principal angle and you add 360 degrees. K belongs to the integers. Not that it's super important, but someone usually points out, could k equal 0? Because that's an integer. And the reasoning is, well, 360 times 0 is like adding nothing. So is an angle coterminal with itself? I don't know. That's sort of very philosophical. I don't think it really matters, but there's probably someone out there going, well, I actually think it should be k belongs to the integers and k cannot be equal to 0. To be honest, I don't think I really care. Your textbook doesn't write it that way. They just write k as an integer. As long as you just kind of get the main idea. No one's too fussed about it. Okay, so here's a couple examples. Draw 2 angles that are coterminal with 135 degrees. So drawing 2 angles is really simple. Now, the challenge with this is because they're both occupying the same space, or their terminal arms in the same position, how do you actually draw the angles? Because 135 degrees looks sort of like that. But how do I draw a second one? I don't just overlap a bunch of lines. That's sort of silly. So the way that we actually draw coterminal angles, yeah, you're going to draw your terminal arm, and you should try and get it as good as you can. This is a 135-degree angle. And I did this sort of in the last little example. I didn't really explain this, so let me just show you. The way that we would actually correctly draw a coterminal angle is we could, well, we could go in the negative direction. So there, we could do it like that. But if you're doing in the positive direction, you would actually do kind of, I call it the snail, because it kind of just wraps around like a snail. So let me just change color just to really differentiate this. This would go here, and it would go there, and it would spin around, and you're not going to actually draw it this humongous, but that's the idea. Okay, so you're showing in this sort of spiral drawing thing. In reality, you're going to make the spiral a lot smaller. Anyway, so what is this angle? We would take 135, and we can see we've done a full 360 on top of it. So that is 495 degrees. That is a coterminal angle. And the other one would be, so how do we actually calculate this? The way we calculate the blue one here is if we went a full rotation in the negative direction, we'd have negative 360. But we're going 135 in the positive direction. So we're actually adding 135 degrees to it. So that would be negative 225. So if you're wondering, how do I kind of get these, just as a formula without doing all this thinking here, we could always use the formula where we could say a coterminal angle, we'll take the principal angle and we'll add 360 degrees, and then k belongs to the integers, whatever. So what we're doing here is we're taking 135 degrees and then we're adding 360. That's how I got 495. So you're just saying k is 1, or you're going 135 and you're subtracting 360. So that's how you get negative 225. That's a little different than what I did, but it's essentially the same thing. I said negative 360 plus 135. We're going 135 minus 360, same thing. Anyway, there we go. There's a couple coterminal angles. And of course, this is what you get when k is equal to 1, and this is what you get when k is equal to negative 1. Don't get too don't overthink the k thing, right? K just means it can just be 1 multiple of 360 or 2 or negative 1 or negative 2 or whatever. Okay, 1b is negative 2025 coterminal with 135. So the approach here is if you solve this equation plus 360, k, put a little degrees there, and k is an integer, then the angle is coterminal. So there's a simple way of doing this, and if you have a calculator handy, if you're really good at adding 360s, you can just go 135, and then on your fingers you go 135, then you add like 360, and you add 720 and 1080. You can actually solve this using the formula. So we would say negative 2025 is the coterminal angle, 135 is the principal angle, and then we'd have 360, and you'd be solving for k. Solving for k, I didn't really leave myself enough room here, but we moved the 135 to the other side, so this would become negative, let's see, 2160, I think, equals 360k, and then we would divide both sides by 360. So this is where you go, okay, 2160 divided by 360. Okay, let me just jump over to Desmos. 2160 divided by 360, and we get 6. So what happens here is that this turns into k equals 6. So therefore, we would say negative 2025 is coterminal with 135. And again, you could also pick up your calculator, take 135, and just keep subtracting 360 as many times as you want, but this is a way to solve it. Okay, and then 1c, determine all the angles that are coterminal with 135 in the domain. So here we're now restricting the domain. Theta must be between negative 360 and 540. So the formula, of course, is very simple. It's 135 plus 360 degrees times k. And what we can do is we can then solve. Now, there's a lot of different ways you can do this. If you want to be very organized about it, you could think if k equals 1, then we're going to get the coterminal angle equals, you're just adding 360 one time. If k is equal to 2, we're going to add it 2 times. So the coterminal angle would be, let's see, what 720 plus that, so that's 855. We can actually see already this is outside the domain, right? We can't go bigger than 540. So now we'll go k is equal to negative 1. And we already know what that is. The coterminal angle is negative 225. And then we go k is equal to negative 2. And what you're basically doing is you're just going to find a bunch of values and see which ones fit in the domain. And if you're even moderately smart, you can probably pretty quickly determine that. There's no point in me even calculating anymore because I found all the values. Just because why not? Let's just do this. Okay, so I got to go, let's see, subtract 360 from that one. I think we're at 580. Okay, so this one's also out of the domain. So what we could say is therefore only 495 and negative 225 are coterminal. Okay. Another example, determine the principal angle of negative 908. So what I would personally do is I'd pick up my calculator, or I'd use my brain, and I'd add 360 enough times until I got a positive number. So we're simply going to add 360 until we get a positive angle. It's not really like a formulaic way of doing this. Any attempt to try and do this very rigorously will probably just get more difficult. So we've got negative 908. We're going to add 360 to it. Adding 360 to it, holy smokes. Okay, well, I got to do a little bit of math here. That's going to be negative 608, negative 548. And then we're going to add 360 to it again. And we're going to wind up having, what's that, negative 188, I think? And then we're just going to add it one more time. And we can actually see this will get us to the answer. I just got to make sure I'm not going to screw this up. I think I have 172 if I'm doing this correctly in my head. So determine the principal angle of negative 908. That would be 172 degrees. Just to confirm, I'm going to jump over to Desmos. I'm going to say negative 908, and I'm going to add 3 times 360 degrees just to check my math. There it is, 172. Cool, and that's it. So just maybe like a little note here, we'll say stop at the first positive angle. Okay, 2b, use the principal angle to write an expression for the measure of all the angles that are coterminal with negative 908. Okay, so what we just did was we figured out the principal angle. That's not really a hard thing. This is not hard either. This is more of just a notational thing. So if you're asked to write an expression for all the coterminal angles, it's the same thing, right? This is the general idea. This isn't really going to change. K belongs to the integers. That's important. And then we say the coterminal angles are therefore 172 degrees plus 360 K, where K belongs to the integers, would be my specific answer for this specific question. And that's it. Well, for this slide. So sort of the whole point of doing all this, I mean, it's all fine and dandy to realize there's a bunch of different angles in the coterminal principal angle, just know the words. But the whole point of doing this is really, when you're solving trig ratios, you always want to get down to the principal angle, and it's especially important when you're doing special triangles. Calculators might not care so much, but when you're using special triangles, you can't use, like, there's no triangle to calculate sine of 545 degrees or whatever, even though that might actually have a special reference angle. Bonus mark in the comments if you tell me if that's true. I just made that up. So anyway, let's just determine the exact value of some of these. So these ones here, I'm going to guess sine of 1215. That is some special triangle angle, but I don't know what this looks like. So what we're going to do is we're going to convert this into its principal angle. So theta p, that's going to become, this is, actually let me use an equal sign, because it is the same if you just write equals. Now, I got to figure out what the heck is this angle. So somewhere off on the side, I'm going to go 1, 2, 1, 5, and I'm going to subtract 360. And I'm pretty good at estimating here. How many times do I have to subtract 360 to get it down to the smallest positive angle? I think it's 3 times, because I know 3 times 360 is 1080. So what is 1215 minus 1080? That's going to be 135 degrees. So it turns out that by knowing the principal angle, maybe I'll just go up here, this is the principal angle. So it turns out this is the same as sine of 135 degrees. They are exactly the same. There's literally no difference. So you might as well just calculate sine of 135 degrees. Now, how do we calculate this one? We have to think back to a lesson or two ago where we had to work out angles in the second quadrant. So this is also the same as sine of 45 degrees. So the idea here is I'm converting to the principal angle, and then from here to here, I'm using the reference angle. And if I know the reference angle is 45, then I can simply go do. Here's this guy, 1 root 2, here's 45 degrees. And then I can say from here, therefore, reference angle equals, not reference angle. Therefore, I can say this is equal to the ratio 1 over root 2. So I know the reference angle is 45, and that gives me a sine ratio equal to 1 over root 2. Just keep in mind that I have to decide whether positive or negative should go in front, but what I can see here is I can see that this is a quadrant 2, therefore sine is positive. So remember, all students take calculus because we're in quadrant 2. That's the S, which stands for sine. Okay, so this is actually my complete final answer. And if I go to my calculator and I type in sine of 1215, and if I'm in the right mode, you always have to check, right? Especially using Desmos. If you're in, okay, so I'm in radian mode, I don't want to be there, I want to be in degree mode. If I type in sine of 1215, I get 0.707, which it turns out is precisely the decimal value of 1 over root 2. So there we go. We figured out sine of 1215 without a calculator. If you had something different, like sine of 1210, that would require a calculator, and then you could probably just go ahead and type it in. Anyway, you'll find that most of the time in the textbooks, because they don't want you to use a calculator, just like I don't, you'll get these nice special angles, so look for them. Okay, for negative 600, so again, I'm going to do a little thought processing here. We've got negative 600, and I can tell I'm going to have to add 360 2 times, because that's 720. And that's going to give me 120 degrees. So that's my principal angle. So what I would do is I would say this is exactly the same as tan of 120 degrees. Again, we're just converting to the principal angle. And then what I would do is I would say, okay, well, what's the reference angle? And I know the reference angle for 120 is 60. So what I'm thinking here, again, this is the reference angle. So the triangle that I'm going to draw is this one here. There's my 60. This is 2. The big side is root 3, and the small side is 1. So what I can say is tan of 60 equals opposite over adjacent, and the opposite over adjacent will be equal to root 3 over 1, or just root 3. So this is root 3. Now I have to decide, is this positive or negative? And I look at this, and I can say in quadrant 2, again, because that's quadrant 2, I can say tan is negative, because in quadrant 2 up here, only sine is positive. So what I do is I'm going to stick a negative sign in front of this. Ta-da. Dunzo. Okay, so there you go. Tan of negative 600 would be equal to negative root 3. And a real quick check, we could even type this in, tan of negative 600, and we get negative 1.73, and that's precisely what the square root of 3 is. Okay, now let's give this one a shot here. Find the possible values of theta, where theta can be anywhere between negative 360 and 720. And we're told this. This is sometimes confusing for people because, like, why am I told what sine and cosine are? The hint here is that this tells you, because sine is positive, it tells you it's in quadrant 1 or quadrant 2. But because cosine is negative, this tells you that it's in quadrant 2 or quadrant 3. And again, ASTC. So if sine is positive, it's here or here. If cosine is negative, it's it's either here or here. So since I double circled that, this one's got to be it. Okay, so what I can conclude is I can say, therefore, we're in quadrant 2. That's why you're given two angles, those two ratios. You're not actually given two angles, you're given two different ratios, but you'll notice they're both the same angle. Anyway, okay, so that's the clues to tell me what quadrant we're in, and that's important because now we just know that we're simply some terminal arm in quadrant 2. So what we do is we now say our reference angle equals, and when you're looking at this or this, we can see they both are referencing, but they're both actually referencing this triangle over here, this special angle triangle. So we can say 45 degrees is the reference angle. In quadrant 2, my actual angle, my standard position angle, which we've just not been putting any subscript under it, is equal to 180 minus 45, so it's equal to 135. Now let's just be clear about something. What we just figured out, this here, that's the principal angle. So now we can say the coterminal angles, which are the principal angle plus any multiple of 360, okay, belongs to the integers. So we can say that it's 135, and we can add 360 degrees as many times as we want. So the thing is, now we have to deal with this. If this wasn't there, we'd have an infinite number of answers, and leaving it in this general form would be fine. But because we've got the domain restriction, we're going to solve for theta c, the coterminal angles, in the domain negative 360 is greater than theta less than 720. So what we have to do, and we really don't have a lot of choice here, is we're just going to simply make a list. We're going to list them all out. So I'm going to start with 135. Now, again, you can see that we can't go lower than negative 360, so we're simply going to subtract 360 from it. I can tell that negative 225 would be an answer, and if I subtracted 360 again, I'd be at negative 585. So just kind of going in a list here, let's see, that's 495, and then we'd add 360 again, which would bring us up to what, 855, and then we really don't need to keep going. So what I just did is I listed out a bunch of different values here. Okay, this is if k was equal to negative 2, and this is k is equal to negative 1. So you basically just add 360 or subtract 360 a bunch of times. It's really helpful to put it in order, and you just get all these, and you could continue the list onwards, right? It keeps going on forever in both directions, but we can see which ones we need and which ones we don't need. So this guy's a dud and this guy's a dud, and we can see that only these fall in the domain. I don't know if fall is the right word, but they're in the, now let's call it solutions. Solutions that are in the domain. Okay, yeah, so we get those three answers. So those three answers would be the angles that give me a ratio of 1 over root 2 when I take the sine of it, and I would get negative 1 over root 2 when I take the cosine of it. Nifty. Okay, question 2. This one's pretty similar, but there's one little difference here. We're told tan theta is equal to negative 2 over 3. Now, what makes this question so different than the last one here? In the last one, I gave you two different values, sine and cosine. Here, I only give you tan. So this only gives you one clue. This tells you that theta is in quadrants. Okay, so again, A, S, T, C. Tan is negative here because it's negative 2/3. So it's either in 2 or 4. So this tells us it's in quadrant 2 or it's in quadrant 4. And we actually don't know. So we've got to find solutions in both of those quadrants. So what we do is we're still going to work out the reference angle. Now when you look at 2 over 3, that is not a special angle. If it was, we'd use a special angle triangle thing, but it's just a calculator question at this point. So we'll go inverse tan of, remember the idea is you ditch the negative sign when you're doing reference angles. It's just so much easier. Okay, so we go inverse tan of 2 over 3. Now we'll jump to Desmos here and we'll go inverse tan because we've got to calculate what that is. Functions, you can go inverse tan, and this is 2 divided by 3. So there's 33.69. Okay, so 33.69. Cool. Okay, so now we have the reference angle, but we have to split this up into a couple scenarios. So this gets split up now. I like to do it this way. I like to do quadrant 2 and then I like to do quadrant 4 and basically just treat it like 2 separate questions from here on out. So theta is equal to, in quadrant 2, we always go 180 minus the reference angle. In quadrant 4, we actually always go 360 minus the reference angle. So these trig questions kind of have a way of just splitting up into multiple questions here. So 180 minus 33, that's 146.31, I think. And then 360 minus that is 326.31, I believe. I'll trust those are correct. So, okay, these are our 2 principal angles. So this is really important to realize what we just worked out. These are principal angles. So if we want to get all the angles, now we can say that the coterminal angles will go 146.31 and we'll add multiples of 360 because we can spin around as many times as we want, and the same thing happens over with this guy. This is going to be 326.31, and we'll add multiples of 360k. And again, both k belongs to the integers. You should write it every time. Okay, so what are all the answers we get? And this is where you definitely want to make a list. So you can start with k is equal to 0, but I can see we need some negative angles in there. So I'm just going to start with k is equal to -1. I don't have to do -2 because I know if I go 2 rotations, I'm going to go way more than -360. So what's 146.31 minus? Oh, okay, well I thought it was being pretty cool here by skipping steps, but you know what? Let's double check all my work while we're here. Okay, 2.69. Okay, I got it. Cool. Now we're going to take that and we're going to subtract. So 146.31, and we're going to subtract 360 from that. We're going to get -213.69. -213.69. 146.31 is the other one, and if I add 360 to it, we'll just go up here and we'll just add 360, then we get 506.31. Great. I can see that 720, if I added another 360, I'd be outside the range, so that's it. Those are all my angles that I can have in quadrant 2. In quadrant 4, I would do something similar where I'm going to go 326.31. So let's actually do this. In fact, I can leave this here, except I can go 360, and I can subtract 360 if I want. So I get -33.69 is one of my angles. In retrospect, I probably didn't need a calculator to do that one. I can also add 360 to get 986.31. I don't need to work with the middle one. 986.31. And I can already tell, right? If I subtract any more multiples, I'll get less than -360. If I add any more, I'll go beyond 720. Okay, so there we go. So how many answers are there to this question? It turns out we have 6 possible angles. So if I went 10 and I stuck any one of these answers in, I'm going to get -2/3. That's what we just solved. Let us just try testing at least one of them. Let's go to 10 here. Let's erase that. And let's go 10 of, oh, it doesn't like this. 10 of, and let's just pick one of the values. Okay, all you people watching, just shout a value out and I'll put it in. Okay, thank you. That was very helpful. So I'm going to try 686.31. So let's go 10 of 686.31, and what I can see is it's equal to negative 0.6 repeating, which we all understand would be negative 2/3. So that's exactly what I wanted to get, and that's what I got. You could try it with all the other values. So there we go. One question, 6 answers. The possibilities are endless. All right. Thanks for watching. If you like the video, click the like button. You can also subscribe. And if you like the sound of my squeaky chair, feel free to donate some money so I can get a better chair. Just kidding. You can't bribe me with chair money. That will not give you more marks. Okay. Anyway, bye for now.